Welcome viewers. In this episode of BRM TV, Phil Parker adds weight to rolling stock to make it better balanced, and I demonstrate basic soldering on an etched brass kit. Before that, here's Byworth MPD, a layout from our recent Peterborough exhibition.
My name's John Gay, I'm a member of the Wickham and District Model Railway Club, and this is my layout Byworth MPD. Initially this layout started life as a little demo layout. I do a lot of DCC installation, DCC sound, and I wanted to showcase what I could do with my locos. Eventually it kind of got invitations to other exhibitions, and in its own right it's progressed from there. The layout's been in existence for about 5 years, and 3 years it's been in its form it is now. So originally it just started as a flat board just showing the locos, but it's progressed into a full-blown exhibition layout now. So the layout, it's 4'6" by 18 inches, so it's a very small footprint, and basically I've gone for a lot of low relief kind of buildings. So building here for instance is cardboard with wheels material packs overlaid and painted. You'll see at the back of the layout there's an old Airfix shed which we had laying around at the club room, which I literally picked up as a complete kit and pretty much put through a bandsaw to make it into 2 low relief buildings. Byworth is a completely fictional layout. The idea was to do something small and compact, so we used an Ian Futers track plan, and I'm very much a Midland man, so I tend to model more the Midland rolling stock. So at the moment I've got a BR1F on the layout, which you see just tucked in at the end of the engine shed there. I've got the Ginty, which has always been one of my favourite locos. It was the first loco I was ever bought as a kid. And we've got a 3MT just sat at the back there, and a bit of moonlighting from a Southern loco, which is the USA tank, which is model rail, which I've just done a full DCC installation for. The layout itself was designed by myself and a chap called Ron North from the Model Railway Club I'm part of, and it was kind of an interesting way to sort of showcase the layout. So we came up with a design, we did a sort of rough sketch, and then I went away and went on to like AnyRail and started doing a digital printout. AnyRail is a piece of software, I believe it's free to download, but it will enable you to basically give a footprint to the area you want to build the layout in, and you can basically play about with all the different track on there. So you'll have your Pico 100, your Pico 75 is all laid out on there, and basically it just gives you the ability to drag and drop and basically place the track where you want it to. Obviously it will also tell you if you're doing curves a bit too tight as well, so that's an added advantage when planning a small layout like this. I liked the idea of bringing a bit of atmosphere to the layout. When you look at some layouts, you've got the sound, you've got all the little added features that people put on the layouts, but to actually be able to sort of change it from night and day lighting with the interactive lighting as well, so lights will come on as it goes into night time. It just brings a new feature to the layout, and of course you're also giving more atmosphere to an MPD, for instance, by having things like the flickering fireboxes inside my locomotives. Wiring wise for the layouts, I always say there's 2 types of DCC. There's simple DCC or there's advanced DCC. This is obviously bordering on the lines of advanced DCC. It's a bit more than 2 wires under there. To be honest, it's a bit of a mess of wires under there. But it's all there for a purpose and it's all there for a function. We've all heard of the software JMRI, and what I'm running that through is a little tiny Raspberry Pi, which is connected to a touchscreen on the front of the layout, which gives us control. That then goes on to a Ewenbrock Daisy 2 system via a computer interface, and that basically gives me control of the layout. I then create a Wi-Fi server where I can control the layout from an iPod or an iPad. Also, the red indicator is also showing where the locomotives are on the layout as well, so there's block detection on the layout. The touchscreen also allows you to change things like the points, the signals, operate the crane and the water tower from the touchscreen itself. Yeah, so JMRA is a, again, free to download interface for computing. So you'll need a DCC system that enables you to have a computer input to it, but it gives you the ability to program your locos into the actual software with things called a roster, and you're able to then, instead of having F1, F2, F3 on your function keypad, you've actually got labels to basically say, this is the whistle, this is the brake, and that way you're not looking like a bit of a wally, basically hitting the guard's whistle by accident when you actually want a whistle to pull off. I would like to do a Mark II version of this layout. So doing this layout has taught me a lot of things, kind of Achilles heels, a lot of kind of choke points that the layout has. So I'd like to try and expand on that, maybe make it slightly a little bit longer, the locos disappearing into the engine shed through the doors, which I will probably end up animating. So this particular layout, unfortunately, this will be the last show that it attends for sort of the calendar. Unfortunately, at the moment, I'm in the process of moving up north. So I've kind of held off taking exhibition invites at the moment until I've made my relocation happen.
Okay, so it's a while since we've discussed soldering on the DVD, and I thought today that we'd take a look at some basic soldering techniques and sort of introduce, for those of you who aren't familiar with soldering techniques, what's involved and how easy it is to solder something together. I'm going to build today a little kit from 7 models. It's kit number D2, a plate layers hut, which is really straightforward to build. So whilst the instructions recommend using a straightforward standard super glue, I think that actually soldering is a great way to introduce you all to some of the basic techniques. So with that in mind, let's get inside the pack and get started. To cut parts from the fret, you can use one of 3 tools. A Stanley knife if the etch is very thin and parts are delicate, a pair of small cutters, again if tabs are fine, or a pair of tin snips which are better for larger parts. I'm choosing the small cutters for this kit because they avoid distorting parts in the fret, and much like a plastic kit, all parts must be freed before the build is started. Okay, so now all of the components are cut out and laid in front of me. It's a good opportunity to familiarise myself with the instructions, which are, as you'd expect from a kit that has been designed on the computer, very clear and concise and easy to read. Many of these components have still got the little tabs left in place, and the next stage, of course, when you're building a kit is to make sure that everything fits together properly. So I'm going to get rid of them, and there's a few ways you can get rid of tabs on kits. If it's a plastic kit, for example with sprues, it's easier to use a little sanding stick because it can cut through quite easily. But with brass, I tend to find that a good selection of needle files does the trick quite nicely. And I've got a selection here. For instance, if you were looking to remove a tab on a section which is a sort of a curved profile, you could use a needle file with a curved profile like that. Most of the time though, you'll find that a flat needle file like this will do the job nicely. Now these are cut in different ways. You can have ones that have got 1 cut, 2 cut, depends on the number of cuts for a particular file. But in essence, the important factor to remember is that the more cuts it has, the smoother the profile of the blade is. So if you want to remove a tab on a very thin piece of etch like this, it's better to have something that's not too aggressive so that you don't start to bend or deform the etch in place. So something like that, which is I think it's a 3-cut, yes, 3-cut file, will do the trick quite nicely. You can pick these up at your local exhibition or with many of the retailers in the magazine pages of BRM that advertise. So check them out, get yourself a set if you haven't got one already. So I've got everything cleaned up, instructions are in front of me, and it's basically just a question now of soldering everything up. So I'm going to start, as the instructions indicate, with the outside of the building, and you'll note that in this little plate layers hut we've got 2 windows, and these are a 2-part piece which need to be soldered together. So to do that, I'm going to, as you can see they are very small, I'm going to use something that's called a flux. Now a flux is an acidic material which can be either in a fluid, very fluid format such as this. This is soldering flux from Wilder, reference SF01, or you can get it in a slightly thicker format such as this one. If I can just get it open, there we are. This is more like a paste format. Either way, when you apply heat to this, what it does is it will create a bit of an acidic etch into your metal when you are soldering your piece into place, and it gives the solder a better hold into the brass itself, and it also means that you can use less solder for a given joint. With that in mind, I'm going to get started with some of this soldering flux. I'm going to use the liquid one on this. I'm just going to use a little brush here, a very small one, and just apply a tiny bit around the edges of the window frame, like so. Now it's important that we keep the half etch on this side because this is going to be the inside of the building. With that in place, we can now take our little window there, which you can see is beautifully etched, very, very fine, intricate detail. It is quite handy to have a set of tweezers at this point, and I'm just going to put that face down into the little half etched groove there. Make sure that it's in place. So there's a variety of solders on the market. Some have got a flux core, some haven't. If you're using flux, it really is irrelevant. I'm going to approach the iron and the solder at the same time on this component, and I'm just going to start off on the top right hand corner here. So solder is now down on the component. I'm going to apply a tiny bit of heat, and there we are. That's one corner into place, and you can see that the part's lifted a bit. So this is what's called a tack. So we've got that into place now. We can refine it by applying a little bit of pressure downwards with the tweezers, and applying the heat, we can just move our component into place like so. Just make sure that everything lines up correctly. And you can see with applying the heat and that flux, we can just flow that solder round two sides already. And you'll note also that I'm now working on a piece of wood. Don't work on a plastic table or anything that's likely to melt. Just work on something that will absorb a little bit of the heat without taking away too much. So for instance, a metal surface, if you're soldering on a metal surface, it's likely to draw a lot of heat out of your soldering iron, and therefore you'll need to put more heat into your components as a result. A little bit on the other corner there, like so, and just work it round. Now the more solder that you apply, the more you have to clean up, so it really pays to just apply the minimum amount required, make sure that you get everything neat, and hey presto, we've glued our little frame into place. Okay, so with those little window frames now soldered into place, we can do a little test fit there on the back of the etch to make sure that they look okay, which they do, fit nicely into place there. And well, building the rest of the kit's merely just replicating those same techniques that I demonstrated, approaching the iron to the solder which is already on the component, making sure that everything's clean, and of course there's a little bit of folding required as well. Now to do the folding, I'm just going to use a steel rule. Everything here that you can see on the kit has a half etch line, which makes folding of components really easy, but to make sure that you get a nice crisp fold along the edge, just align them into place at the back there like so, and fold it over. Sometimes it can help using the back of a pair of tweezers just to make sure we get a crisp fold as well. Let's get folding and soldering, and we'll catch up when the kit's built.
I prefer to use a fluid flux for parts, but if something needs to be tilted at an angle and it might run, the flux paste is best used here. Apply a little 60/40 tin lead solder, and approaching it with the iron is a simple way to guarantee a solid join.
So the chimney's made of about 5 components in total, each very intricate and fine, and they all need soldering on top of each other. This can create a little bit of a problem when it comes to soldering, because you can't always get access to the soldering iron under each individual component. So I'm going to demonstrate a technique known as sweating. Now what we're going to do here is just apply a little bit of solder to the top of the chimney here, a very small amount, like so. With that soldered into place, I'm just going to apply a tiny bit of solder flux to the top of the chimney, and then on goes the little chimney cap. It's probably easier to use some tweezers at this stage. I'll try and work that into shape so that it looks square with the other components. A lot of soldering is just fiddling with parts to get them to sit properly before you actually apply the heat really, but there we are. And I'm going to hold that in place with the needle file as I apply the heat, just to make sure that it all stays square
and in place where it should do. Apply a tiny bit of solder to the underside of the iron to transfer some heat through the iron down onto the chimney. And make sure that's all worked around. Take the heat off again, and that's all set. And there's another chimney cap to place over the top of that. And just dip that straight in the flux, there we are. And this one goes right on the top in the centre there. And then we've got this little tiny chimney pot which sits on the top, just like so. So what I'm going to attempt to do is hold all of these into place whilst I apply the heat, and hopefully nothing should slip out of place. Let's hit that with some of the heat. You get a good hiss from the solder as it takes with the flux, and you can start to see the solder seeping up through the top of the joints. And what we're looking for when we apply the heat of the soldering iron is a nice shiny surface, which means that the solder is taken properly and evenly all the way around. One chimney into place, a very intricate part as you can see, all the different little components there on top of each other, but there you go, that is the technique of sweating.
This little kit from 7 models is a very therapeutic build. It's not taxing if you're a beginner to soldering, and better still, because it's not a model with working parts, it's less critical if you find you haven't been as accurate with some of your soldering. Even if it doesn't turn out as planned, you could easily hide some of your mistakes by a little ivy on one side of the building. To see how an etched building can be painted, download the January 2019 issue of BRM from pocketmags.com/BRM.
Today I'm going to be talking about putting on weight. Now I find for putting on weight, nothing works better than donuts. Few of those and lots and lots of weight put on. But the trouble is, for model railway wagons, they're completely hopeless. It doesn't matter how hard you push them, they're just not going to fit. We're going to need something a bit more sophisticated. Now, if you build kit build wagons, then you'll find one of the biggest problems is they are very, very light. And even certain ready-to-run wagons can be a little on the light side. So at some point, everybody has to think about how we're going to make these things a bit heavier, because when they're heavier, they will run better. They'll stay on the track, they'll deal with lumps and bumps, and they'll just make it much more pleasant to operate the layout. The first question you really have to ask is, how heavy should my wagon be? And there are lots and lots of rules and formulas. NMRA of America has a set of rules based on the number of axles on a wagon, and it's all very complicated. To keep it simple, what I reckon is pick one of your heavier existing wagons, place it on a set of scales, and this is a Dapol wagon, which is one of the heavier four-wheel wagons I've got. Just put it on there, and this comes in at 35 grams. So what I'd like to do is I'd like to make sure all my four-wheel wagons are about 35 grams in weight. That means at least consistently they'll all run the same over the track. So if the track's fine, then all the wagons will behave exactly the same way. And if there's a problem at one point, it'll be a problem with the track, not with the wagons. What's in the bottom of these wagons is one of these. This is something I've hauled out of a ready-to-run wagon, and it's a steel bar. Steel bars are easy to produce. I think you can often get these things as spares as well for ready-to-run things, and they're usually just sandwiched in between the floor and the body. So somewhere underneath the bottom of the floor and the body, this thing's sitting there. It's got a hole in it because you can see there is a screw that goes through the middle of it. That's great, but unless you've got a little foundry in your back garden, you're not going to be making steel bars. And to be honest, they're not really the best thing in the world either. There are lots and lots of options, and invariably it comes down to this stuff, lead. Now, I'm looking at a couple of wagons I've built here. I've got a van and an open, and let's start with the open. This is a Parkside 24.5 ton mineral wagon kit, and as you can see, it's got loads of space underneath, but of course it's open on top, and that means you can see in it, so I don't really want to put anything in there. I want to hide all the weight under the floor. So I have some lead. Now this is lead flashing, which you can buy from a builder's merchant. I know people say, oh, you can go and get it free. Sometimes you can, sometimes you can be lucky, but to be honest, 9 kilograms of this stuff on a roll, nice and clean, not covered in pigeon poo, that will be £34 when I looked it up last night, and there's pretty much a lifetime supply for most, certainly 4mm wagon builders and probably 7mm wagon builders as well. And it's great, it comes on a roll, it's very, very malleable. As you can see, I can bend it really easily, and I'll glue it into the bottom of the wagon. If gluing it in is a bit scary, Wix will also do you a nice 2.5 kilogram roll of self-adhesive flashing, and that's only 14 quid. So, yeah, we're really not talking a lot of money to go and buy lead straight off the shelf. I'll just cut it, big pair of scissors, that's all you need. You don't need anything sophisticated. Tin snips will work, and that comes in at 20 grams. So I need about 15 grams of lead. That is 38, so I want just under half of that. 17, knock a little bit off the side of that, that'll do the job. There, that's 16, that'll do. And that actually will slide in underneath between the wheels. Now what I'm going to do is I'm just going to flatten it out with my fingers. You can use a pair of pliers if you want to bend it in half or anything like that. If I take the scrap piece, you can see that I can bend a piece of lead really easily, squash it with the pliers, and there you are. It's now twice as thick and half the length. If you get really desperate, I will recommend the wooden mallet. The wooden mallet is a fantastic tool for dealing with lead because you can just gently tap it on the side, and you can make it thinner and wider, or if you tap it on the side like this, it'll get shorter and fatter. Anyway, I've got my little strip there. I've managed to cut it so it's just narrower than the wheels, so the wagon will still run nicely. Now, you can use super glue. I prefer a rubbery glue, like either a contact adhesive or in this case Yoo-hoo. I find that that sort of deals with the lumps and bumps when you're running your rolling stock a little better than the super glue, which can be slightly brittle. Now, just a quick check that the wheels are running nice and smoothly. Back on the scales, 35 grams. There we are, job done. That wagon is now heavy enough. Once the glue's dried, it'll run nicely on the layout. For vans, and this is a 12-ton plywood sided goods van from Parkside, offers a lot more possibilities and a lot more problems. The first problem is, if we look underneath, this is unusual for a Parkside kit in that you've actually got all the underfloor framing, which can just get in the way. If you want to put a sheet of lead under there, you either need to hack out all this stuff, build the wagon up with the floor upside down so all this framing is inside the van, and the great thing about vans is put the weight inside. You can look at other sources of lead. You can obviously use lead flashing. These are the sort of weights that you get for balancing car tyres. Tyre places will often give this stuff away. They've got a bucket load of it because they take it off the wheel, they throw it in a bucket, and then they have to do something with the bucket. So if you've got a friendly tyre fitter or you've just had your tyres changed, ask them if you can have some of the lead weights, and often you can get them for free. If not, you can buy these things, strips of these things, for about £4 online. Having said that, one thing I will say is if you're going to put the weight inside the van, test the van on the layout before you glue the roof on. Because trust me, I have glued the roof on to a van and then realised it's too heavy, and boy, does getting that weight back out again really cause you a problem. However, I'm actually going to try and fit the weight underneath, because what I'm going to use is another version of lead, and this is what we call liquid lead. It is very, very, very tiny, tiny, tiny little lead balls, and they behave like a liquid. Best thing to do is put them on a teaspoon. You need something, an old teaspoon I should say, or one that you've nicked from the film crew who won't notice. Basically, you pour these things into the bottom of your wagon, and this is where all this framing is actually going to be a big help to me, because it will hold the liquid lead in place. So I can pour the liquid lead into the bottom of the wagon. It's probably a good idea at this point just to give it a bit of a check on the scales. That's 26 grams, so I want to put a bit more of that under there, and it is really, really messy stuff. Clever people will be working on their workbench over a box or something to catch all this stuff. 35, bang on. Right, we have the liquid lead. What I'll do is gently tap the wagon, the floor of the wagon, and the lead will run around. Okay, the wheels are still going around, that's important. Do check the wheels still go around. And then all I've got to do is fix it. Now, you might think to yourself, this is like ballast. I could fix it with PVA glue. And indeed, you could pour watered down PVA on there and it would fix the liquid lead. The problem is that PVA reacts with lead and expands. And this has been a problem for people who use this sort of technology to weight up. Locomotives, they've filled the boiler with liquid lead and it's great and it's added weight where you really want it over the driving wheels. They've filled it with watered down PVA, that's held it in place. And for a couple of years everything's fine. And then gradually, over time, the lead and the PVA expand and the boiler bursts. And yeah, it bursts seams, it knocks smoke box doors out, it really ruins the model and there's nothing you can do about it. So the simplest way, and actually the most effective way to hold the liquid lead in place, is actually just a few drops of runny super glue. And you've kind of got to soak it in there because the lead and the super glue won't react. And you want to use a nice runny super glue because obviously you want it to seep in around the lead, and then leave that to dry for a couple of hours, just to be on the safe side. And there you have it. You have a wagon. You can see it's actually already holding, the glue's already holding it, but I like to leave that to dry for a couple of hours. And that is the wagon weighted up to match the ready-to-run wagons. And as I say, one of the things you can find is some ready-to-run wagons, you've got a bit of framing under there, you've got plenty of space to put something like liquid lead, and you can apply the liquid lead in there in exactly the same way I've just done in this one. Bring all your wagons up to about the same weight, and you should find your layout will run a lot more reliably. And that's great. Time now for me to relax and have a donut, but safety first. Always wash your hands after you've been handling lead before you start having something to eat.
And on that note, this brings an end to this episode of BRM TV, but take a look at the extras menu to watch a splendid layout from this issue, Stoke Courtney.